are talking about blood indices and how to interpret them. We're really talking about the normals and how they can skew from the normal. And instead of just talking about holistic numbers, we want to talk about indices. And in order to come up with those indices, we look at how much of the hemoglobin is in the red blood cells in comparison with the size. So in terms of size, we're looking at macro, normal, and microcytic. So this is how big the cell is, and then on the amount of hemoglobin, we're looking at chromic. So chromic comes from the word color. So we're looking at hyperchromia, normal, or hypo. So in looking at the levels of red blood cells in individuals, we're literally looking at how much chromia and how big are the cells. So I mean, it goes without saying that a normal chromic cell that is of a macrocytic nature really won't do much, or a macrocytic cell of hypochromic nature will really not do much. And so even in describing the types of diseases, we are going to deal with describing this aspect of them. So maybe just to elaborate on a few things. First of all, you want to state that the reduction or the increase is measured by indices, and aside numbers, whole numbers, the size and the color of the red blood cells is very imperative in acknowledging the amount of red blood cells in a human being. And so if there is a reduction in the ability, and ability would mean less hemoglobin, that would result from either less chromia or less size, or holistically less number. We have what is known as anemia. Now, when we have anemia, it's because of several reasons. So let's go through these reasons. Let's start with one that is known as megaloblastic. So in megaloblastic anemia, I'll start with the description. It's mega, so you know that the cells are large. So just from the cytic, we can tell that the cells are large. And not only are the cells large, but we find that they appear, or they come to this because of a lack of vitamin B12. And then we also have a deficiency in folic acid. Now, both of these are required in the production of red blood cells. And we find that these cells easily rupture, because the reason why we have ovoid cells, that they easily go through the capillary, but if they're large, they can easily rupture. So if they're rupturing, it means that we have a reduction in the number of red blood cells. And if we have a reduction in the number of red blood cells, we are getting to this or a reduction in a holistic number of red blood cells, and hence an inability to do what red blood cells are supposed to do, leading us to anemia. So that's megaloblastic anemia. The second type that I would like to talk about is pernicious. So in pernicious anemia, we see it being a result of reduction in vitamin B12 as well. We'll talk about it in detail very soon. But what I would like you to know is that um, others would include aplastic, which occur due to a damage in the bone marrow, and also hemolytic anemia, which is excess distraction, and this occurs a lot in sickle cell, where the red blood cells easily are are destroyed, and we cannot just go about mentioning that these are hyperchromic or normochromic. We have to use numbers, and numbers help us to determine things more specifically. So, what numbers do we have in the description? Okay. We'll get back soon, but let's go on to another one. Okay, so in today's lecture, we are focusing